Now, let's look at the weak charge. If we look at the D quark, we will see that the weak charge on the U quark port is 1/2, but on the associated boson minus, it is -1. So the total weak charge on the D quark is -1/2, which is indicated by the standard model for a left-handed D quark. Now if we look at the S quark, which has a spin of 1/2, then we see that the weak charge is 0, which is also indicated by the standard model as the correct weak charge. And if we look at the associated or emitting boson 0, we can see that a weak charge of -1/2 is being carried away. And if we look over here at the U quark, then we see that on the left-handed D part, then we have a weak charge of -1/2, but that is being flipped by the associated boson plus by a weak charge of 1 to be +1/2, which is the weak charge indicated by the standard model for the left-handed U quark. Now, if we look at the C quark, then we will see that we have +1/2 for the C quark, which is a left-handed spin particle, which is what is indicated for the left-handed C quark. Now let's look at isospin. Now the isospin for the D quark, we can look at the U quark port and see that it is 1. And if we look at the boson minus associated with it, we see that it is -1. So -1 with 1 makes a -1/2 isospin for the D quark, which is indicated by the standard model. And then if we look at the S, we will see that we have 1/3 and -1/3, which is 0 for the isospin on the S quark. And if we look at the emitting boson 0, we can see that a -1/2 isospin is being carried away, leaving the 0 on the S quark. Now we can go over to the U quark and see that on the D quark part of it, we have the indicated isospin of -1/2, which when the identity is changed to a U quark, we have a +1, changing the overall isospin of the U quark to +1/2, which is what is indicated by the standard model. We go down to the C quark and we'll see, just as for the S quark, we have -1/3 and +1/3, giving us 0 isospin on the C quark. And we can see that +1/2 is being carried away by the boson 0.